Okay, so we're going to talk about vertical and horizontal asymptotes. The first thing we're going to discuss is just a little bit of theory behind it. A vertical asymptote is essentially where, if we have some graph, it will not touch an imaginary line running through the graph. So I'm going to create a vertical asymptote at, we'll say 4 here, but I'm going to call this C. Okay? So what this means is our function f at x, when x is equal to c, so that's what our vertical asymptote is, we're going to test it, and we're going to test the limit as x approaches c. So as x is approaching this asymptote here, so as it comes at it, and this negative sign here means from the left. We've talked about this before when we were talking about limits. So when we're approaching this asymptote from the left with our x, well, since this is our x-axis, approaching it from the left would mean coming at it from this angle. And if it's greater than 0, so in other words, if our function, when we plug in our c, approaching from the left, so some value greater than c, if our function ends up being a positive number, okay, what that means, and we just mean minusculely greater than c, not just any value, that means we're going to have a function that is going to be heading towards positive infinity. Okay, so we'll do that one in black. For greater than f at x, think of it like this, and it's heading towards positive infinity, okay? So our asymptote is heading up and up and up. It'll never touch that line. The same idea could be said if we have a limit of that, a different function, we'll say this time. This is still our c value, our vertical asymptote. If we're approaching it from the, oh my gosh, I can't remember left and right. Yeah, it's the other way. The left is from the other side, for all of those who know their left and right. So this is approaching from the left, and then heading upwards. This is approaching positive infinity. It's still the same as long as the function is greater than 0 at a small value larger, or sorry, in this case, less than. I said larger because we said from the right before. Less than our c value. And our red function is going to represent f at x when we're approaching it from the right. Well, the right will be the first time we came at it. This is the right. So if we're approaching this asymptote from the right, and our function, when it's just a little bit larger than our c value, is greater than 0, that means we're going to have a vertical asymptote that it again is heading towards positive infinity. Okay? So anytime we're a little bit larger, we plug in a number a little bit larger or a little bit less than our vertical asymptote. If we get positive values, that means we're approaching positive infinity. Okay? We're going to go over the same idea. This time I'll get my left and right correct, I hope. This one here is our limit as x approaches c. This is c again from the left, which means this way. Okay. And if we're approaching c from the left and our function, when we plug it into our function, our c value, if our function is less than 0, so we have a negative value, that means we're going to have some asymptote. Now, if you guys notice, I drew it along the x-axis. I'm going to do that again. We'll talk about horizontal asymptotes after. But as we come at this, it's going to start heading downwards. In other words, towards negative infinity. So that means what we have is a function heading in the direction of negative infinity, so going down forever. And the same can be said if we're approaching it from the right and we're less than 0. Well, it's the same idea, just coming at it from the other side. It's approaching negative infinity. So what I want you guys to take from this is if we have a positive or negative value, when we take our asymptote, when we're finding the limits towards it, if we get very close to it and we're finding that our limit is a negative value, that means it's heading downwards towards the asymptote, just along it. And if it's the other way, we get a positive value, that means we're heading upwards. Okay? So that's the theory behind vertical asymptotes. We're actually going to deal with a question now. So we have this question. It's the first example in your textbook. I've already made up a chart, but don't worry too much about that. We have this function here. Okay? In order to find a vertical asymptote, we're dealing with the denominator of our rational function. Okay, so we have rational functions here. And then when doing asymptotes, we're dealing with rational functions most of the time. Okay, any polynomial function, just as a function itself, will not have an asymptote towards it. It'll be a continuous function. So what we have here is the bottom of this function here cannot be 0. For if it is 0, we end up with some value 0. This is undefined or undetermined. Okay, in other words, we're going to have a vertical asymptote at this point. Now we need to find values of x that will give us 0 on the bottom. So we're going to take the bottom of this, or in other words, the denominator of this rational function, set it equal to 0. We have x squared plus x minus 2. We're going to factor it. When we factor this, we get x minus 2, x plus 1, which means x, in order for this to work, cannot be the values of 2 or negative 1. Okay? So at those points, we're going to have vertical asymptotes. What I'm going to do is we're going to put in a graph here. Oh. Let's move it down. So what that means is we have a vertical asymptote on this graph at the value of 2, which is there, and at negative 1, which is here. Okay. So we have that information so far. Now what we're going to do is we're going to plug values in around those. Okay. So what I mean by values in around those, let's go back to our page width here. Value of x. Well, because we have our asymptotes, I'm going to look for the value of x when it's coming at the number. We'll start with, should we have had positive 2? Did I write this function right? Negative 2. Oh, sorry. This should have been a positive, and this should be a negative. So these are vice versa, negative and positive 2. Okay. So, first thing we're going to look at as negative 2. As x approaches negative 2 from the left, we're going to figure out what our function is going to be and then what it's approaching. We're going to look at as x approaches negative 2 from the right, will our function be positive or negative, and therefore which way is it approaching the function. And the same idea when x approaches 1 from the left and when x approaches 1 from the right. We're going to plug in values just a little bit smaller and bigger than these into our original function, which is our f at x. We're going to find out if they're positive or negative. And depending if it's positive or negative, it's going to give us either positive infinity or negative infinity in terms of which way the function is approaching. Okay. So, when doing this, we're looking at the original equation here. Okay. So I'm going to drop down to the bottom of this thing, and I'm going to rewrite it and do some work down at the bottom of the page. So, let's move down. Our original function f at x, and remember our values were negative 2 from the left, negative 2 from the right, positive 1 from the left, and positive 1 from the right. Our f at x function was x divided by x squared plus x minus 2. Well, it'll actually be faster if we work with our factored form of this on the bottom. So we're going to deal with f at x is equal to x divided by, and we're going to write our factored form, which we factored to find what the zeros were, which were x plus 2 and x minus 1. Okay. So when we say approaching negative 2 from the left, we're looking for a value of something like, let's say, negative 2.01. Okay? So we're a little bit larger. We can obviously get much, much closer, but something like this should give us an idea of which way we're approaching. So if we put something like that into our function, so I'm going to put our function, we'll do this one in blue. Our function as x is negative 0.201. Well, that's going to give us negative 201. And below, well, negative 201 plus 2 is going to be negative 0.01. And with our 1, negative is going to give us negative 3.01. Okay? What's important to realize here is I have a negative times a negative. Really, we're just going to look for signs, right? Because we only want to know if it's positive or negative. Our values aren't as important. They are technically points on the graph. But we really want to know, are we positive or negative, so we know if we're approaching positive or negative infinity. Okay? So what I'm going to really do here is I'm actually going to replace these values. And I'm just going to write this is a negative on top. And we're going to think of our multiplying and dividing rules. A negative, and then I have a negative times a negative. Well, what's that going to give me? A negative divided by a positive, which gives me a negative term. So, if I have a negative 2 when approaching negative 2 from the left, so here our function is negative, f of x is approaching what? Negative infinity. Okay? Let's do that same idea, approaching it from the right. So approaching negative 2 from the right, where we're looking at a value of like 1.99, negative 1.99. That's very close to negative 2, but coming at it from the right. So let's talk about f at negative 1.99. When I plug that in, remember, I plugged in the values the first part, but really what I'm going to focus on is whether I have a positive or negative value. So my top number on top of this fraction is going to be negative when I plug that in for x. When it affects this here, positive 2 plus this number, well, I'm actually going to get a positive. It'll be a really small positive, but it will be positive when I add those together. And then when I have negative 1.99 minus 1, well, that's going to give me a negative value again. Okay? Well, if that's the case, I'm going to have a negative divided by a negative, which is going to give me a positive answer. So what that means now, when we plug that into our function, when we approach negative 2 from the right, we have a positive answer. In other words, we're approaching positive infinity. So let's kind of try to make sense of that. That was our negative 2. What that meant is as we came at it from the left, we were approaching negative infinity. And again, we don't know what numbers come across. Let's just use our x-axis as our line for now. This was coming at it this way, was heading down towards negative infinity. And when we approached it from the right, depending on where it is, I don't exactly know, it was approaching positive infinity. So that's two parts of the information we found. We need to carry out the exact same test with approaching positive 1 from the left and right. Same idea again. Left of negative 1 will give us 0.99. Okay, so let's talk about putting that into our function. F at x when it's 0.99. Now remember, we had an x on the top of the equation, so this is a positive value, so I'll have a positive on top. And let's just go reference the bottom here. If I plug in 0.99 positive into this part, we'll get a positive. And if I put in positive 99 into this, well, I'm going to get a negative. So I'm going to have a positive and a negative here. Is that right? 1.99. Is it 99? Yeah. Okay. So what that means is we're going to get, where's my green? Like we said, we're going to get a positive value here and a negative value here. So we're going to get a positive and a negative. Well, that's going to give us a positive divided by a negative, which gives us what? A negative value. So when coming at 1 from the left, our function is negative, which means we're approaching negative infinity. And finally, let's say we approach it from the right, we'll use 1.01. Same idea, our function at 1.01. Well, our function at 1.01, we end up with a positive on top because it's just a value of x. We're adding positive 2, so that's going to be positive also. And finally, whoops, over here, if I put 1.01 subtract 1, well, I still end up with a positive value. So we have positive, positive, positive. We're obviously going to get a positive answer. So our function is positive, which means we're approaching positive infinity. So when we go down to do the other parts of this, when we approach negative, sorry, not negative, but 1 from the left, we're heading towards negative infinity, so we have something that looks like this. Again, we don't know where the inversion point is. We're just going to continue it from here. So we're going down. And when we approach it from the right, we're heading up towards positive infinity. Okay. So just keep that in mind, that this is positive infinity with a vertical asymptote, and this is our negative infinity, even though it looks like a weird 8.